Our topic today is CCTC, which means congruent parts of congruent triangles are congruent. Actually, the corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. Right? Our essential question, if you know two figures are congruent, what can you conclude about their corresponding angles and corresponding sides? Corresponding. We're going to try and use CBCTC to prove parts of a triangle are congruent. Okay? We'll see that this is a just essentially the next step beyond those 5 congruent theorems that we talked about Tuesday and then y'all did it yesterday. Okay? Hopefully you didn't waste yesterday. Hopefully you didn't waste it. If you know all that stuff from yesterday, you can talk about it. I know most of y'all probably aren't done with this, but I gotta move on. All right, here we go. CPCTC is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. It can be used as a justification and a proof after you have proven 2 triangles are congruent. All of it. Side, 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 angle, angle, and hypotenuse leg use corresponding parts to prove triangle congruent. See, really? CPCTC uses congruent triangles to prove corresponding parts are congruent. Say what? I would write both of the boxes. This is an important thing that you need to commit to memory. Moving on here. All right, check this out. Watch how this works. Watch how CPCTC will work in a real-life problem, not a real-life problem. Because I don't know how many times you're going to be on different sides of the ravine and wondering how far across you can go, especially if it's 18 miles. Would not suggest it. But let's check it out here. It says one angle pair is congruent because they're vertical angles. So right off the bat, you should be getting to see this particular theme that keeps happening whenever lines are crossing each other. That problem. This verb, this angle and this angle, what are they? What do you know about vertical angles? They are good. 80 is 10 miles, congruent to 10 miles. It's 15 miles, congruent to 15 miles. Are those 2 triangles congruent? What here? Good. Side, angle, side. Okay. Side, angle, side. This triangle and this triangle are congruent. So, Katie, what is the measure of AB? How do you know that? And what does that mean if they're congruent? All you told me was that 10 was congruent to 10 and 15 was congruent to 15. Yeah. So, because the triangles are congruent, their corresponding angles and corresponding sides are congruent. That's how CPCTC comes into play. So once you prove side, 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 angle, 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 side, or hypotenuse leg, that two different triangles are congruent, you can then have one last little step, which is called CPCTC, to say that all the other sides and all the other angles would also be congruent. Okay? Got it again. Dylan, what do you know about these 2 angles right here? They are what? Yeah, what do you know about vertical angles? Good. Dylan is 19 congruent to 19. 30 congruent to 30. Which theorem would prove that those 2 triangles are congruent? SAS. 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 Side angle side, side angle side. So, Dylan, what is the distance from J to K? Y. Perfect answer. It's congruent to MN. How is JK congruent to MN? Say 5-letter answer. Starts with C. Starts with C.
Oh,
CPCTC, right? CPCTC, corresponding parts of congruent triangles are congruent. Corresponding parts of the congruent triangles are congruent. Okay? Right. Look at this one. If YW bisects XZ, and XY is congruent to YZ, prove to me that XYW is congruent to ZYW. Mr. Payton, what does bisector do to an angle? Two what? Two congruent angles. So I am bisecting those angles, okay? I'm going to change this question up. I'm going to go YXW, okay? It's congruent to YZW. All right. Even, what other information was I given right here? XY is what? What does that mean? So XY is congruent to YZ, correct? Now, even this one isn't given to me, but what's the big elephant in the room on this problem? Is there another side that's congruent? No. YW is congruent. YW is congruent to itself with what property? The reflexive property. Even, are these two triangles congruent? This one and this one. For what theorem? Side, angle, side. Side, angle, side. Okay? So through side, angle, side, so this would be the first thing I'd say. Through side, angle, side, triangle XYW is congruent to triangle ZYW. Okay? After I say that, I can then do one simple thing. CPCTC tells me angle YXW is congruent to YZW. Okay. I can say that YWX is congruent to YWX. I can say that XW is congruent to ZW. All the other angles, all the other sides that I haven't already used would be congruent because of the CPC. So if you're baking a cake, you start off with all the ingredients, right? Correct? You gotta like mix it all up and all that good stuff. That's what we did last week. Last week we talked about congruent triangles, congruent corresponding parts, right? Corresponding angles, corresponding sides, two different triangles. Mixing all of it up. Then we got to do the hard part, which is make sure the concoction that we made is actually going to what? Rise, taste good, right? That's the hard work. That's side, angle, side, angle, side. I'm not each leg. Trying to figure out what the heck's going on when I can go to this triangle, correct? CPCTC is like the frosting. Okay? When you get to the point where you can use CPCTC, your work's pretty much done, correct? This basically says everything else is congruent. Yay! Get me out of this class. All right. We're going to skip over this one. What's that? Yeah. No. Okay. I think I'm going to skip over this one because we haven't done parallelograms yet. We'll get into this. I put this in here thinking that we would have done them by now, but we haven't. So I'm trying to prove, I'm sorry, if it's given to me, you know what, I'll go through it with you guys. If NO is parallel to MP, and if angle N is congruent to angle P, I'm trying to prove that MN is parallel to OP. Okay? Step numero uno. What do I know about angle NOM, and angle excuse me, PMO? They're congruent. Why would they be congruent? What theorem? Challenge. These two angles be congruent. Through what theorem? That would be similarity. Just the angles. How do I get angles to be congruent to each other? Yeah. Perfect. I was on. I got two parallel lines cut by a transversal, right? Two parallel lines cut by a transversal. The alternate interior angles would be congruent. Told you these transversals, they're gonna come back over and over again. Okay. It's hard to see because it's a shape, but this is the only thing that's in that problem right now. Parallel lines cut by transversal. How would these two angles be congruent to each other? They're alternate interior angles. Okay? Alternate interior angles. Now, how is MO congruent to itself? Adriana, how is MO congruent to itself? Perfect. Anytime I say something's congruent to itself, you should think the reflective property. Okay? All right. Okay. Now, angle, side, angle, side. See that? Angle, side, angle, side, angle, side. I've got two congruent triangles. Corresponding parts will be congruent to each other. If the corresponding parts are congruent, that means that these two angles will be congruent to each other. I've got two pair of alternate interior angles to tell me, this is where that converse would come in. Converse of the alternate interior angle theorem will tell me that the lines that create those angles are parallel. Question? Well, starting from P, I have angle, side. Which side? NO or PO? I don't have. All I have is that side's parallel right now. Okay, all I've got is that side is parallel. Sides could be parallel but not congruent, right? See what I'm saying? Yeah. Until I find that this is parallel and that's parallel, I do not know that they're congruent. Okay, good question. All right. You're going to see a little bit of this today as well. Okay. All right. How would we use CPCTC in a coordinate plane? Say how? You would stick, first off, obviously point one, plot the figures that you're given. Okay, that's point one. Part two is the fun part. You know what? plotted these points? Class. Which theorem do you think we're going to use to find whether or not these triangles are congruent? What? Side, side, side. I don't give you any angle information. Okay? I'm not going to ever tell you in a coordinate plane, hey guys, plot these points. Oh, by the way, find the angle measurement too. Not going to happen. All right? So just, if you see plotting in a coordinate plane, you should think, okay, we're doing some side, side, side stuff somewhere. Okay? Y'all remember this. How do we do side, side, side? We use our 6 times when we use it. Yeah! Woohoo! Okay, you'll notice that DE and GH have the exact same measurement. DF and GI have the same measurement. HI and EF have the same measurement. So I'm going to go back here. I can do this. Now Miss Guy's on. Side, side, side. Yep, 2 different triangles, 3 pair of congruent sides. I would be able to conclude. Yeah, this is formula. Guys, this is formula. Yeah, you should have this memorized. If you don't have that memorized, we need to do it now. Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Here. I'll leave it on the board for you guys. What? Yeah, that was it.